Hello, my name is Seamus Delaney, and on behalf of my colleague at Deakin University, Madeleine Schultz, first of all, can I say thank you to the organisers of this conference. Our presentation is called Big Boom plus Fire equals Iron, Experiences from Systems Thinking Orientated Chemistry Outreach in Primary and Secondary Schools. The name will make a bit of sense later on. A systems thinking approach in chemistry education acknowledges that many of the 19th and 20th century solutions offered to society by chemistry have become our 21st century problems, such as plastics, photochemical smog, and fabrics. Chemists need to take a systems thinking perspective to address the global, holistic, complex nature of challenges like sustainability. We can start with that by perhaps starting to think about the material basis of society as a core element in sustainability challenges. One way that that might look is to then shape the practice of chemistry to take that in consideration. We could be reorientating our chemistry education to address the sustainability of Earth and societal systems. And what would that look like in the classroom? So it might have a focus on educating for the molecular basis of sustainability using systems thinking. That brings us to, again, looking at the materials basis of society. In this project, we've taken the lens of looking at endangered elements. What are endangered elements? Well, an endangered element, as shown here on the periodic table, is thinking about elements that are starting to run out, have a limited supply due to overutilization in society. That gets us to think about, where and what they've been sourced from, what are they used for? And so what can we do about it? In the classroom, that might mean, whilst many students are pretty good at talking about endangered species, we're somewhat proposing, wouldn't it be great if our students could also talk about endangered elements? Our project involved a chemistry-based school outreach program. It was targeted at upper primary and lower secondary students, so sort of age 10 to 14-year-olds. And importantly as well, we used other students from the school, be it middle or senior secondary students, as student leaders in this program. It was modelled on a very successful program here in Australia called the National Indigenous Science Education Program. We designed all of the activities and experiments in consultation with chemistry and chemistry education researchers to really make sure that we incorporated contemporary science practice. And importantly, we were really having a strong focus on choosing activities that could demonstrate the relevance of chemistry to sustainability. So our key objectives were to have students, teachers and schools engage positively with a systems thinking orientated sustainability focused approach. And as sort of second to that, we wanted to really see how we could work with the student leaders to see them feel like that they were leaders of the chemistry outreach, potentially leading to their greater participation in STEM pathways. Over the course of a few months, not that long ago now, we visited 7 schools across country here in Victoria. Overall, we probably reached over 1,000 students, both as students and student leaders at 7 different schools, at a range of different year levels. Because we had a strong focus on going to rural and regional schools, these were predominantly, they predominantly had a low socioeconomic disadvantage, and we were interested in reaching P-12 schools that never really had an opportunity to engage with outreach like this before. What did it involve? Well, first of all, we'd turn up. We'd turn up in our big ute full of all of our chemicals, and we would set up, and then we'd have a session with the student leaders. So we would have organised with the school to have the student leaders ready before they come, and we'd have a session with them in the morning. So for 90 to 120 minutes where they'd test all the activities themselves, we'd discuss with them, and with our university volunteer students, to help them engage with the activities and how they could then show those activities and demonstrate those activities to students of younger age in the afternoon. That also allowed us plenty of time for our university volunteers who we brought with us These were all sort of undergraduate or postgraduate students at Deakin University studying chemistry, and just chat with the student leaders and have them feel like that they had a voice and agency with these volunteers. The sessions themselves, we would run sessions for about 90 to 100 minutes. Normally it would start with having a bit of an introduction session to the topic, which was periodic table of sustainable elements. Then we'd have roundtables. So we'd have stations, about 4 stations set up around the room where groups would move around and do activities. We would also then have an outro session at the end, again, really bringing home the message of the day, and lots of demonstrations along the way. What were some of those activities that we did? So we were really after activities highlighting elements, having elements as our narrative. So we looked at, we made aluminium air batteries, just simply demonstrating to students you can make a pretty simple battery just with household products. We grew copper crystals on aluminium sheets that have been dunked into an agar solution containing copper ions. We coated zinc. So we took 1 cent coins here in Australia, very out of date, and we coated them with a zinc layer to get a nice silver sheen, and then we blowtorched them to make a nice alloy to get a nice sort of a gold color there, and the students really loved that experiment. We also did some experiments with iodine, electrolytic writing, plugging it into a carbon rod and writing on the surface. Fingerprint messages disappearing, anything really around that theme. One of our highlights was working with Professor Stuart Batten. So again, thank you very much, Professor, who provided a material periodic table briefcase. If you see there on the bottom right-hand corner, students being able to hold and handle samples of elements, including mercury was a very popular one. On the left, you see as well, we had these periodic table sets. So it's a set of 33 elements that students could then arrange on our periodic table of endangered elements. And so that brought up a lot of conversations. We also had some gallium with us. Gallium had a nice connection to the periodic table after all, gallium being one of those metals that was discovered just after Mendeleev proposed his periodic table, which gave some nice evidence. So it was a nice link to the periodic table story, but also gallium being a very important metal in this context. By far, our favorite was also our thermite reactions. So we'd always end with reacting aluminium powder and iron oxide to form a nice big fire. And then we would dig out some of the materials that were left afterwards to show the formation of iron. Aluminium was an important element for us throughout this outreach. It wasn't because it was an endangered element, far from it. It's over 8% of our Earth's crust. But it's a fantastic one to talk about chemistry linking to energy. After all, it's suggested that over 3% of the global energy electrical energy production is used just to process aluminium. Recycling could do that for 1/20th of the amount of energy. So it was a great to really talk about the amount of energy required to make aluminium. And what better way to show the amount of energy that goes into making aluminium is to then release that aluminium through a chemical reaction, as you saw there. We did a lot of evaluation. So we followed ethics very closely. We got informed consent along the way, so we were able to get pre and post from students, student leaders, our university volunteers, the teachers that we worked with. We interviewed the teachers. So we're really starting to go through a really nice, strong look through all the data that we've collected. A few highlights. We were able to show from pre and post that our students did seem to have a statistical significance improvement in their interest in science. And also connecting, again, coming back to that theme for what we were really targeting, was thinking about actually, science is relevant to daily life. There is a relevance to chemistry and science. We were interested to see, could they start to connect the dots? Could they start to see, well, did they feel like they were talking about sustainability? We asked a series of questions. It was interesting to see that some questions they did really seem to change. It was a strong change from thinking about, is conversion of waste into new materials, is that part of chemistry, is that part of sustainability? And so we're really starting to unpack that information now. We were a bit cheeky. We asked them a question at the start of the day. Could they, we gave them 4 elements to choose from, and did they think these were endangered, having not really given them the context of the question. Interestingly, we didn't, asking them the same question after the day didn't really highlight, for 3 of them, they didn't really change. In fact, it was aluminium didn't change at all. But it was very interesting to see zinc change significantly. They really started, a huge shift in how they saw zinc. So that was fantastic, because we'd had so many conversations throughout the day about how zinc is used for galvanization of steel, and that's one of the reasons why its overuse is one of the reasons why zinc is really one of those elements that we're worried about. We gave them a chance to provide some open comment back, and some of the comments were enlightening, shall we say. It definitely showed to us that the coin experiment, turning the copper coins into silver and then gold, was very popular. Hence the name of this title, one of the comments that came back was big boom plus long fire equals iron. That was written by a primary school student who saw one of our thermal reactions. It was fantastic that he thought of iron. We have also got some data from our student leaders. We were interested here perhaps more to think about, did they feel like their understanding changed? Because they were there the entire day with us. They had the experiments in the morning, and then they had to demonstrate those to students from their school of a younger age. We were able to sort of, if the data suggests that they did have an increase in understanding of science, but importantly for us, there was also an increase in sustainability. They really started to connect the relevance of chemistry to sustainability, which is what we wanted to see. And also the data did seem to suggest that they started to have an increase in interest in sustainability from this program. They gained confidence with working with other students to do through the experiments. They felt like their knowledge of sustainability increased, and they really loved the opportunity to work with the younger students as well. One of the comments as well was working with the university volunteers. So here you see in the picture some of our lovely volunteers in white working with our student leaders in blue. Many great conversations, and hopefully students still remember those months later. We did seem to suggest that they did. We interviewed the teachers roughly 3 or 4 months after each of the school visits. There was evidence to suggest that they really did attach the program with the idea about increasing student agency, developing their leadership skills. They loved the fact that the experiments were hands-on. Students could really get in there and do them themselves. They felt like they were speaking with actual scientists and actual researchers, which was nice. But also for us, we didn't want this to feel like they were just like another science day. So this idea that they could, the teachers and hopefully the students as well, could start to see how what they were doing really connected across all of their subjects. There was as one teacher said here, there was a bit of a humanities part to what they were doing. So that was a nice result to see. We're starting to really code through those interviews now. Of course, positive came up a lot. All the teachers interviewed at each of the schools highlighted the positivity of the learning experience. Other things like helping students with confidence. The comment, we've also seen that perhaps some of the content did go over their heads. After all, we were working with some quite young students. Our youngest students were in grades 4 to 5. So maybe some of that went over their head. Also, the scheduling for the day, trying to do it all in one day was a big ask. So maybe we're looking at how we can spread that out over a few days in the future. So thank you. We really should acknowledge the tremendous amount of support that we received in running this program. It was financially supported by the Australian National Commission for UNESCO. We were very lucky to win a grant for the International Year of the Periodic Table. Some of our colleagues and eminent scholars in the science systems thinking field, we've been very lucky to have conversations with. Our internal support, the Deakin Science Society Network, working with our colleagues at the National Indigenous Science Education Program and the Deakin Research for Educational Impact. So thank you very much. And of course, I really must say thank you to our university volunteers. You can see here in some of the pictures, they've been fantastic and come on the journey with us, and some of them will still come with us in future ones. And of course, the schools and the students that we worked with. You can find all these resources all the activities we made are available on our website, eschemistry.org, or Elements of Sustainable Chemistry. Thank you for your attention.